Welcome to a minor series video. In this video, we are going to look at how we can prove the cosine rule. So there are two key things that we'll discuss in this lesson. Firstly, it's the diagram, and then we are going to look at the proof itself. Before we get to the diagram and the proof, it is very important to remember the distance formula. When we learned about the distance formula, these are the two versions that we learned about, and for our proof we are going to look at version number 2. Now the question will most likely present itself in this version, where it says in the diagram below, triangle ABC is drawn with A at the origin. In some questions, B will be at the origin, and in some questions, C will be at the origin. So in this case, it's A that is at the origin, and this dictates the type of proof that you are going to be asked. So it says, use the diagram above to prove that small letter a squared is equal to that. Now, if B was at the origin, then you'll be asked about small letter b, and if C was at the origin, you'll be asked by for the version of with the small letter c squared, and with C at the origin. Now, when I showed you the two possible diagrams, I showed you that you can either have an acute angled triangle or an obtuse angled triangle. And from the previous diagram in the question, you can see that you have an acute angled triangle. So you will get something like this from your diagram sheets. What you need to do is to add the coordinates. So at the origin is 0, 0. Then you have B and you have C. You also label the sides, small letter A, B, and C. And then, of course, very important to remember to draw this dotted vertical line, which is your height for this triangle. You label your height and you label the end of your height at the x-axis. Now here's the proof. We start by writing down our distance formula, BC squared. We chose BC because it's the side of small letter a. So small letter a squared, and then if you look at the x-coordinate of B, it's C cos A, and the x-coordinate of C is B. And again, if you look at y, your y-coordinate of B is C sine A, and your y-coordinate of C is 0. So it's just a substitution step. Now we simplify. So on the first term, you have a binomial squared. So all you do there is just expand and have two binomials. And then on the second term, C sine A minus 0 will be C sine A, and if you square that, you'll get C squared times sine squared A. Now if you expand your binomial, you are going to get what you see on the screen. Now the two red terms will be your middle term, and I marked them red so that you can see and be able to check them as we continue with our proof. Now minus BC cos A minus B cos A will be minus 2 BC cos A. It's now the last term. And then I took B squared to be our first term, and then the two terms that had C squared to be our two middle terms, and I marked them green for a reason. Now if you look at them, those two middle terms, they have something in common, and that is c. So we take out a common factor, c squared rather. So when you take out c squared as a common factor, what you are left with inside the brackets is cos squared a plus sin squared a. Now if you have a keen eye, you would realize that cos squared a plus sin squared a is a trig identity, and it's equal to 1. And then you can write your final answer, which is what you were asked to prove in this question. What is important to remember, of course, is that depending on what the question is asking, then if it's asking for A, then A should be at the origin. If it's asking for B, then the vertex B should be at the origin, and so forth. So you just modify your diagram accordingly.